Okay, so in exercise 5e, question 4e, we're asked to solve this equation in this interval for theta. First thing I would check is that my equation is in terms of tan theta, and my interval is also given in terms of theta. I don't have to do anything to change that. If it was tan 2 theta or 3 theta or something else, then I would change my interval. The next thing, I need to rearrange this to get it down to tan theta equals something. So I'm going to just change 0.4 into 2/5 so that I can manipulate it without a calculator. And I'm going to add 5 to both sides to give me 2/5 tan theta equals -2. So 2 tan theta is -10. Divide by 2 now, tan theta is -5. At this point I can pick up my calculator, make sure it is in radians. Theta is the inverse tan of -5, and that gives me -1.37 to 3 significant figures. Now this principal solution that my calculator has given me is actually out of range. That's okay. All I'm going to do is I'll reject that solution. That won't count in my answers. I'm going to, because tan repeats every 180 degrees, every pi, I'm just going to add pi to this answer. So if I add pi to that, my first answer is 1.77. If I add pi again, I get 4.91. Add pi again, I get 8.05. Add pi again, I get 11.2. I've added pi 4 times. I started from below 0. 4 pi would be 12 point something, 12.6-ish. And so I've got all of my solutions within range. Two things that I would do at this point is I would just check with the diagram. I'd probably go for, in this instance, I'd go for just my normal diagram of tan in that given interval. So thinking about it, tan is 0. I use it. Tan is equal to sine over cos. So I know that tan is 0 every time sine is 0. So that would be at 0, at pi, at 2 pi, at 3 pi, and at 4 pi. Let's say 4 pi. And tan has an asymptote whenever cos is 0. So my asymptotes here are at pi over 2, at 3 pi over 2, and so on in between each of those. In terms of the shape of the tan graph, goes something like that. And that's it in that interval. So what am I expecting in the interval between 0 and 4 pi? To get -5. So we're actually looking somewhere down here on the axis. -5, I'd have 1, 2, 3, 4 solutions. Good. I could also look at this using the cast diagram. And if I were to do that here, sometimes it's easier using this kind of diagram, the original graph, and sometimes it's easier in cast. It's sort of pick and choose. Right, so in the cast diagram, I'm thinking my principal solution here that gave me a tan of -5 was -1.32. So it's coming down here. Now this would be minus pi over 2, which is about 1.5, -1.57, -1.6. So -1.37 would actually take me into this quadrant. That's the angle, -1.37, that gives me a tan of -5. Cos in this quadrant would be positive. They're all positive in that quadrant. Sine is positive there, and tan is positive here. So the only other quadrant where I would get a negative tan would be up here. And I would get tan of -5 from this angle. And also, if I've got minus 1.37 above there, that would give me tan of minus 5 as well. So from my point here, what we're doing is we're adding pi to get us around to this angle here, and that is our 1.77, which is basically 3.14 minus that 1.37 takes us to there. So there's my first answer. If I add another pi to get back down to this line, that's my 4.91. Add another pi, gets me back to that line, is my 8.05 up there. And add another pi, my 11.2 radians is represented here, which is below 4 pi, or about 12.6 numerical value. I think, yeah, the easiest one in this instance is to use that diagram as a check rather than cast here.